Okay, so the recording has commenced, and now we move to the slideshow format, and I'm going to close down the meeting controls. So if anybody wants to talk to me, you'll have to make a chat on the Facebook. So today's talk is about writing our scripts in the 21st century. And this is not about writing in the Roman alphabet, the ABC, but it's about writing in traditional scripts and in new scripts that have been created for different languages in Northeast India. And unlike in previous times when these would be written by hand, using pens, using traditional inks on bark or on manuscript paper, today we're talking about writing on computers. So if we want to type our script in Facebook and on our mobile phones or cell phones, what is it that has to happen? So the first stage is that the scripts have to be included in what is known as the Unicode standard. I'll be talking about this shortly and explaining what that is and how the scripts get included in it. Then the second stage is that fonts will have to be developed, and I'll be talking about that as well. And then keyboards need to be developed to access the Unicode characters. Basically, Unicode has a lot of characters and you need a keyboard to find the ones you want. Then we need to update the operating systems on the various devices that we use. So these are the underlying systems that make the cell phones or mobile phones or computers or tablets, whatever it is that you use. And you may well need to update individual applications, individual programs to support the script or the new characters in a script. In some cases, this is going to mean installing the fonts and keyboards on the device or enabling individual applications such as Word, your browsers, things like Chrome or Firefox, and other applications like Facebook to recognize the fonts. And cell phones, these mobile devices, usually don't allow the user to install fonts. And this means we have to wait until the fonts are part of the cell phone's release version, a part of the updates that happen on the cell phone. Okay, so stage one was Unicode. So Unicode's mission is that everyone in the world should be able to use their own language on phones and computers. This is something we all agree with. So, what is Unicode? So it's a standard for the consistent encoding, representation, and handling of text in most of the world's writing systems. Now, actually, there's a lot of different writing systems, including new ones being created. So Unicode could never actually include everything because there are changes occurring. And perhaps we are discovering even old ones that need to be included. So the standard is maintained by the Unicode Consortium, and as of March 2020, there are 143,859 characters. That's 143,859 different symbols that you can type on your computer if you have the font and the keyboard and everything else that we talked about. And these 143,859 characters are grouped together in 154 modern and historic scripts, some of which we'll talk about shortly. There are multiple symbol sets and in addition, 3,304 emoji or emoji. And I'm not going to talk about them today, but you all know about them and you probably all use them. So what does Unicode look like? Well, what I've done here is to print the screen of the select character insert symbol, I think it's technically called, from the Word, Microsoft Word menu. And what you see is a whole lot of different symbols. And the one that I've highlighted is called Latin small letter A with diaeresis. And its Unicode number is U plus, that U stands for Unicode and plus is referring to its number, U plus 00E4. So 00E4 is the number that it's got, and this is a unique number. Now, Unicode counts its characters using 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. And that makes 16 different positions. So the first one would be 0, 0, 0, 0. Actually, I don't think they use that one. Then 0, 0, 0, 1, 0, 0, 0, 2, etc. 0, 0, 0, 9, then 0, 0, 0, A, then 0, 0, 0, B, etc. So the Unicode numbers are made up of these different things. Let's look at another one. So this is a really easy number to remember, but this is Myanmar letter Ka, and this is Unicode plus 1000. Okay, this is a significant one because the Tai Pake, Tai Aitwan, Tai Kamti, and Tai Kam Yang Ka is also coded in the same position. But it's called Myanmar letter Ka, and that is its code is 1000. And what you can see here is a whole set of different letters that are used for Burmese language, but also for other languages related to Burmese, such as Shan, such as Tai Pake, etc. Okay, so what are Unicode's processes? So the first process is to prepare a proposal for the addition of a script or add new characters to the existing script. So I've been involved in both of these kinds of proposals. The proposal to introduce the Diahom script, which was prepared by Martin Hoskin and myself some 8 years ago, and more recently one to include the late Lakum Mosang's Tangsa script into Unicode, which is being considered at the moment. When the proposal is written according to the structure of a proposal, it goes to the script ad hoc working group. This is led by Debbie Anderson, and I've got a photo of Debbie here, which she provided kindly yesterday, who has been very helpful. And that committee looks at the proposal and decides what changes might be needed to be made to make it fit the requirements, the technical requirements of Unicode. Then the proposal, after being revised, is submitted to the Unicode Consortium's quarterly meetings, that's 4 times a year, and once approved, Unicode will be updated. Well, technically what happens is that the Unicode standard, which is that huge list of 150,000 characters, that's 1,50,000 in India, it's a lot of different symbols. The Unicode standard is published with the new characters or whole new scripts, and then, and this is the important point for today, companies and implementers need to update their software and their fonts and fonts and keyboards need to be created. And sometimes it takes several attempts before a new script proposal is accepted because it has to be revised. And in fact, as Wang Lung Mosang, if he's listening here, will know, we started work on the proposal for Lakum Mosang's Tangsa script to be included back when I was in his house in January, and it's been revised several times. Debbie has taken it to the script ad hoc group. They have made comments on it. We have adjusted it accordingly. Okay, but that's not the end of the story. So what does a Unicode proposal look like? So this is a sample of part of the proposal that Martin Hoskin and I put together in 2012. So it has a number at the top, a technical number which refers to the document. It has a date. It has the name of the International Organization for Standardization in English, French, and Greek written underneath it. And then it has the details of the document and then an introduction. Okay, so this document was a revision of an earlier proposal about the Ahom script. I'm not going to talk through this slide in detail. You can read some of the background to the Ahom script. The proposal also includes technical details discussing irregular sequences of vowels. So we have to be able to write all the different combinations that are found in the original manuscripts, and we have to explain that in order to write the word for star, we need the Ahom letter na, We need the O vowel sound, we need the O vowel sound, we need the ba symbol, we need the virama, we need the vowel sign U. We need all of these different symbols for at least some of the ways in which the word star is written. So this is very technical, but you'll see that we have to understand thoroughly how the script works in order to be able to do this. And this is the list of Ahom characters that were accepted in the initial application in 2012. In 2015, we added one more, which is in the position 1171A. So where there is currently a dark square, another symbol has been placed. And you'll also notice that some of the little circles, dotted circles, and these are characters which cannot stand by themselves. They need a consonant to have been placed before they can occur. And finally, this is the technical names of the symbols in the Ahom script. I won't spend time talking about that because there's so much more to talk about. Once a script is approved by Unicode, the next thing we need to do is make fonts. So making a Unicode font is more tricky than making a non-Unicode font, partly because the special requirements of Unicode have to be met. So one of those requirements we'll talk about later, which in the case of Thai Ahom is what happens to the E vowel. So, but before I say that, many of the requirements of Unicode, such as the details in the Unicode proposals, are there because they are needed by font developers and those implementing the rendering engines. And this is something we'll talk about again later. So it's not just the font, but also what's called a rendering engine that actually draws the shapes. And all this needs to be working to make the script behave as it's expected on our computers and mobile devices. It's really actually a very complex matter and involves lots of people. So the people I'm going to mention during this talk, people like Debbie and Martin that I've already mentioned and others who I'll mention shortly, are all doing things behind the scene to make this happen. So for example, take the Thai Ahom word ke for river. To write this, you first need to type the letter ka and then the vowel e and then a final symbol which occurs in Thai Ahom when you write words with the vowel e. But this E needs to be rendered, that is to say, to show up the screen as E, then ka. So even though we type ka, then E, and then this final owl symbol, it has to appear as E, then ka, then the final owl symbol. And that is quite a complicated thing to achieve. And it has to be understood at every stage of the development of the fonts, of the keyboards, and of the rendering. Okay, so what does the font making process look like? Okay, so this is my old Pake font that some of you are familiar with. And this has the characters encoded in the position where Roman alphabet letters should be encoded. So for example, 0041 is actually the capital letter A. But that was because at the time that I created this font, there was no Unicode. There was no place to put these. But they can't stay there because computers are not going to be able to recognize this as Thai Pake language if they are in that position. And you can't use this font on Facebook or on your mobile phone for texting. Okay, so one of the solutions to the font making question is the Notto fonts. Okay, so the Notto fonts have been created by the Google Corporation, and there's lots of them, and there's fonts for most of the scripts that we're talking about in Northeast India. And what Notto means is no more tofu. Tofu is what happens when boxes come onto your device when when the system isn't working properly. And we'll see some of these boxes shortly. Okay, there's lots and lots of beautiful fonts in Notto, and So I think I've already said what no more tofu means. That's removing that rectangular symbol. Here's the reference, the link to that article. Among the people making fonts are Ben Mitchell and Zachary Scheuren, and there's certainly many others. And I've been talking to both of them about different aspects of making the fonts work in the way that we want them. And here on this screen, you see where to get the Notto fonts, and you can get them from this address. It's a, it will take some time to download them, and there's an awful lot of fonts there, not all of which any of you will need, but there are some very nice fonts. And here's an example of what they look like at the moment. So here are some Notto fonts, the Ahom one, the Wancho one for the script created by Banwang Losu, and the Notto Serif Myanmar one, which can be used with the Thai languages and which includes the black circles, the little black dots that distinguish these characters, these letters from their Burmese equivalents. So that very first one, that word is Gao. I mean, this says, Gao Taka Kin Kao. I will go and eat rice. All these sentences say something like that, actually. And this one, that very first letter is the ka. It's the one which is placed on the U plus 1000 in the Unicode system. But this is a variant form. And we'll talk a little bit later about the variants because they are one of the issues that are a bit tricky. So this is what it looks like when I made the fonts in the LibreOffice Writer, but there is a problem. In the Ahom, there is a little dotted circle in the last word of the Ahom text, with kau, meaning rice. Why is it there? Well, it's there because the rendering system has not been told, does not understand that the final symbol, or sat, or the killer, or the virama, the final symbol, can occur after the vowel o, which is the little circle below the consonant. Okay, so we need to update the systems so that they understand that. And part of the problem here is that back in 2012, maybe I didn't understand well enough what was going on to be able to tell the original proposal that actually that needed to occur. So it's going to take a little longer before all these fonts work the way we want to. But as we'll see below, making these fonts implement correctly in different programs, or render correctly, perhaps I should say, is quite challenging. But before we talk about that, we need to talk about keyboards. So once we've made the font, that's not the end of the story. Now we need a keyboard to access it, because without the keyboard, you would have to enter into the insert symbol and find the letters amongst the 150,000 or 150,000 other symbols that are there. And that's going to be difficult. So creating the keyboard is important. This can be done in several ways. Using Microsoft Keyboard Layout Creator, and those of you who have been using the Dai Ahom or keyboard that I created would know about this. Some of you know that. Or using Keyman, which is a different program, or you write your own program. But for that, you need technical skills that I don't have. So the next slide shows the layout for the keyboard I made to type Dai Don and type Hake. These keyboards, like MS, KLC, and Keyman, are relatively easily installed on laptops, less easy on mobile phones. Possible, but less easy. Okay, so basically this is a photograph of a keyboard, and the green arrow is pointing to the place where the letter T should be, and what I have done is I have placed the da, the Dai Don Pake Kamti Kamyang Da on that square. Actually, I've done it as a form without the little circle, so it's more like a Burmese da, but nevertheless, it is there, and if I have that keyboard in operation, if I have installed it and am operating it, then that symbol will come up. Okay, just to show you that this can be done with dots, this is a keyboard that has been created by Craig Cornelius, who's another person who's been doing a lot of work with me. Craig spent more than an hour with me this morning talking through this. and is, I think, listening to this lecture, and he knows an awful lot. So you can ask him questions through the chat while you're listening to me. And this shows that we could have put the variant form of da in that same position, the one with the little black dot. And there are lots of keyboards online. So this morning, Craig helped me out by doing a search for Daya Home keyboard, and this is what we came up with. And the first one is the Janabi keyboard created by Utpal Pukan, which we will talk about shortly, which allows me right now, and those of you who are using it, to type Daya Home in your mobile phones. There are others, but in fact, most of these are not keyboards for Daya Home. The first one, Janabi, however, does include that. So if you want to install the Janabi Daya Home keyboard on your cell phone, you have to go through several stages. First of all, you have to download the app onto your phone, and then you have to go into the that's the first slide. The second slide, you have to go into it and you have to enable the Janabi keyboard. You've got to switch that on. As you can see on the first slide on the left, you've got to enable it. And then you have to select the input language, Janabi Ahom, and then you have to change the keyboard, not the Samsung keyboard, but English US, which says Janabi underneath it. And that will allow you to use the Janabi keyboard. I did this morning and I sent a message to Mehdi Mohan that some of you know, and this is the message that I sent. I wrote Udina, which means, are you well? And then soon after that, I had to send a message to my father, and I started typing and it was all coming out Ahom. Reason why, I had forgotten to switch back to the Samsung keyboard. So when you are switching from keyboard to keyboard, you've got to remember to switch back. Okay, so that's making the fonts and the keyboards, but that's not the end of the story. The next part of the story is implementing them. Okay, why isn't this the end of the story? Because every program, every application, both on computers and on mobile devices, cell phones, iPads, etc., needs to be told that the fonts should work. So, if the font is installed as part of the operating system, which for many devices, the Notto fonts will be at certain points, then many applications, especially simpler ones, will just work. So that's probably why it's sometimes easier for me to get some of these fonts to work in Facebook than it is for me to get these fonts to work in Word, or as we'll see shortly in PowerPoint, which is where these slides were made. Fonts that are not part of the provided operating system are going to be less reliable. And the reason is the operating system hasn't been designed to make them work. So it's great that people go out and design their own fonts, and we should be able to do that, especially for printing books and things. But for use on Facebook, it's going to be easier if we can use the existing fonts, even if they're not completely the way we'd like them to look, because adding fonts, particularly on your mobile phone, is tricky. Okay, because a font, now this is quite important to understand, is something that Craig was explaining to me this morning. Because a font that is designed by individual users, one that you make or I make, can compromise the security and privacy of mobile devices. You know, if, for example, I was to create a font that replaced all of the Roman letters with Tai Pake letters, which is exactly what I did 20 years ago, and then put that font onto the mobile phone, it would mean all the Roman script wouldn't look Roman anymore. And that'd be a problem. Okay, so because of that, such fonts are more difficult to install on mobile devices such as our cell phones. So this is a compromise we need to make it possible to text on the cell phone. We're going to have to use a more standardized version of what the font looks like. Okay, So I mentioned before, this slide on the right, we saw this before. This is the way the Notto fonts, the beautiful Notto fonts, I really think they look lovely, look on LibreOffice Writer when I did this a day or so back. But the implementation isn't quite as simple as that, and already there is that little dotted circle. And a dotted circle is a sign that something isn't working properly. Because when I tried to enter exactly the same bit of text into PowerPoint, this is what I got. And these are the tofus, these are the boxes that we were talking about. This is what we want to avoid. So, actually, in the last few days, since I found that I couldn't type the Notto Serif Ahom and the Notto Sans Wancho font, and even some of the letters for Thai language, that's the letter Na down the bottom, would not work. I've been in touch with an international team, including Andrew Glass and Stephen Chua, who are over, I think, in California. Well, actually, I don't know where they are because everybody's all over the world. And they're looking into why these fonts don't work in PowerPoint in the version that I currently have on my laptop. And we're trying to find out what's going on. What is the bug? What is the problem that is preventing these from working? And they don't look perfect on Facebook either. So I put this into my timeline, but I didn't send it to you all because I just wanted to see what it looked like. And this is what it looked like in Facebook. Actually, not this morning, but yesterday morning. But anyway, I've revised these slides a few times. And you see the Ahom comes out in boxes. The Wancho looks fine. The Thai language is at the bottom without the little dots that we want. So the reason why the Ahom script is in boxes or tofu is because Notto Sans Wancho is currently selected as my font on Chrome. So this is Facebook done on my laptop on Chrome. If I change the font to Notto Serif Ahom, what I get is this. What do you think's going to happen? Well, the Wancho stops working, the Ahom starts working, but with the little dots, because that's something that needs to be fixed various stages up the system, and the Thai one is still not showing the dots. But when I change the font to Notto Serif Myanmar, then we get this. We get the black circles, the black dots on the Thai script at the bottom, which is what we want, but the Ahom and the Wancho don't work anymore. So sometimes I'm chatting on Facebook with Banwang Losu about Wancho, with maybe Medi Mohan or Medini Gogoi or Poppy Gogoi about Ahom, and maybe even wanting to talk to some of my Thai friends about Thai Paki or Thai Aiton or Thai Kamyang friends about their languages. And I have to keep changing in the background on Chrome which font should be there. Now, we believe that this should be fixable, but right now we haven't got a solution for this. So this gives you an idea of some of the rendering issues that occur. So some of the tools that are going to make all this work, that are making this work for so many scripts and that are going to make it work for more, is something called the Universal Shaping Engine, which is developed by Andrew Glass. Andrew is the one helping us at the moment to make it possible for Ahom and Wancho Unicode to be used on PowerPoint. And the Universal Shaping Engine, so what is it? Well, a font is like a program, but it has to be run in such a way that the characters appear correctly on the screen and when printed, so that when you send them to the printer, they come out looking right as well. And the Universal Shaping Engine is the tool that does this. It actually draws the characters based upon the shapes suggested by the font. This is a brilliant idea, and I have to confess, I don't understand fully how it works. And this is one of the issues here, that there's no one who understands all the aspects of all of these things that I'm talking about today. And I've had a lot of help from a lot of people to get this together. And Craig Cornelius this morning, my time, told me that he likes to think of the shaping engine like this. If it doesn't work properly, it's like someone listening to a language they only half understand. A lot of the meaning gets lost. So we imagine the shaping engine, if it's not working properly, it won't do all of the things that we want the script to do. It might not, for example, put those dots in that we want on the Thai letters. Okay, when we've got all that working, there's another thing we have to do, and that is to convert our older non-Unicode texts into Unicode. And here Craig Cornelius has made some really nice tools for Diahom and Taipake, and also for converting the Mashong script of Reverend Gam Win into the Lakum Mosang script. And these are the links, and those of you who want to can try these out. I'll show you what it looks like. So at the top is some old data. So this is for anyone who knows Thai language, you'll be able to see straight away that this is a rice pounding song. Khamwa soyoy, soyoy. You can see soyoy there in the middle of the text. And this is converted at the bottom into Unicode. Now the Unicode it converts into is a slightly different font with slightly different shapes, but that's okay, we can deal with that. But you can see that the dots are all still present. And the reason why the dots are still present is that we have ticked convert with variation sequence, and we have ticked Pake variant Unicode. If those things are not ticked, the dots won't come up. But when I copy that into Word at the moment, the dots don't come up. And the reason why the dots don't come up is that the current version of Windows that I have and the current version of Word that I have isn't updated to allow it. Maybe this is because the shaping engine is not fully aware of what needs to happen here. So it should look like the dotted version in the bottom box on this page, but it does look like this, which isn't what we want. Okay, but when I copy it into LibreOffice, a program which works a little better, the dots come up. Okay, but this is a screenshot from LibreOffice. This is not something that I have put directly into the PowerPoint, because there it won't work either. And some of the letters won't work for the reasons I mentioned before. So when I copied it onto Facebook this morning, this was a couple of days ago actually, this bit of text looked like this. Soy yoy, soy yoy, soy yoy. Some of you know the melody of this, right? Saksun, Pinkam, Goy. This is what it looked like. I had to change my settings on Chrome to get the dots working and make it look more like the way we want it to look. So to kind of bring this discussion to the conclusion, I want to mention that it is more complex on mobile devices like cell phones, and there really isn't enough time today to talk about that. And partly I don't fully understand what's involved, but a lot of effort is being made by a lot of people, including many of those that I've named in this. Also, I want to mention Norbert Lindenberg, who gave me a lot of suggestions on this and is helping us out with a proposal to get the dotted forms working better. So the dotted forms is what the Thai Pake, Thai Aiton, Thai Kam Yang, Thai Kam Ti want to see when they write. And this is the way people want to see it. And this is my old font made in 1997, where all these characters are placed in the same position as Roman letters. But mostly what we get is this, and people say this isn't our script because it doesn't have those dots. It looks more like Burmese. Okay, so we want to make that work. And so, as I mentioned Norbert earlier, he's currently working on a proposal to add black dots to more characters, and also to talk with all the different people involved in this process about the best way of making these things work, because the black dots are currently what we call variant selectors or variant forms, and they don't come quite as easily into the system. And Ben Mitchell, I'll also mention, I've had a number of meetings with Ben. So Ben is living in England. Norbert and Craig, I think, and Debbie are all in California. I just don't even know where everyone is. That's the COVID-19 era. You can talk to anyone, anytime, or maybe not anytime. So Ben is working on updating the Notto fonts and making them more, work better for the Taiaiton, Pake, Kamti, and Kamyang. Okay, so the challenges. There isn't, and probably never will be, anyone who understands how the script, deeply understands how the script work, what the writing means, what the texts actually mean, as well as all the technical issues of encoding, implementation, font design, keyboard design, updating platforms, browsers, etc. That's more than any one person could actually know. So it's going to require lots of discussion and meetings and the help of many people, some of whom I've named in this talk, but perhaps not everyone. But we have to make it work so that people can write the way they want to. As Jau Kaling Namanoi wrote to me, in behalf of people, community and users expect a non-complex one, so all ages of Thai users can use it and read it instantly without needing to install some extra programs for the dot appearance. If there's any possible way to get it directly without the need of applying variation for the dots over the Myanmar and Shan Unicode characters, well, we are working on it. We want to make this happen, but it is a complicated process for reasons that I hope I have explained. Now, to finish this talk off, I just want to do one thing, which is to share with you a video that was sent to me by Am Chon from Dibrugarh, explaining the importance of the Thai characters. Here we have the written form. You can see the little black dots. Here we have the translation, and here we have her words.
Am Chon. How Kuntai Pake? Kuntai Pake, how you saw the him, Kenam Ho. The Mung Assam Man Pake Yang Kauman. Kam how lick how, Kung Nung Kung Mai how, Tung how tan how sung song su, how kun kam tra pra, Sing kam how yang huk sing.
And it is exactly because we want to preserve, it is exactly because we want to preserve the language and the script that we are all working together to make it possible for these scripts to be used in the 21st century and used on our laptops and on our mobile phones. And we're going to keep working until this is achieved. So that's the end of my talk today. What I'm now going to do is to